Okay, so P represents you tell me the time, and Q represents I'll pick you up at the airport. So the first premise, if you tell me the time I'll pick you up at the airport, um, that would be expressed in symbolic form as if P then Q. And then the second premise, I pick you up at the airport, that would just be Q. Okay, so the first premise is if P then Q, and the second premise is Q. And when we have an argument, what we do is we put the two premises together with an and. We always unite the two premises with an and then we put the if then arrow, and then now the conclusion. And the conclusion is, therefore you told me the time, which is P. So we take the two premises, which we have here, and we unite them with an and typically we put brackets around it, and then the if and then arrow is always there, and then the conclusion is over here on the right. So this is the argument in symbolic form, which is what they wanted. We would type this into MyMathLab. That's the symbolic form of the argument. I now have to figure out if this argument is valid or not, and we do that with the truth table. So I'm going to construct a truth table. I have my P column, Q column, and so we put the normal true, true, false, false, and then true, false, like we always do. I don't see any nots in this statement. That's good. We need if P then Q. And once I have if P then Q, I can do if P then Q and Q. And once we have that, we can do the whole thing. If P then Q and Q. So if all that, then P. And of course the argument in symbolic form always goes in the far right column. And so now we're going to fill in the rest of this table. If P then Q. Looks like we have true, false, true, true. That's the way it always goes. If P then Q is only false when the first part's true and the second part's false. On the next one we have if P then Q and Q. So of course in order for this to be true, both of these have to be true. And so I'm looking at these two columns, and we have, I see that they're both true. They're not both true. They're both true, and they're not both true. Finally, the last one, this is a conditional, and so anytime the first part is false, this will be true. So I see that I'm looking at this column. Of course, that's the first part of the symbolic form of the argument, and on the second row it's false, so this will be true, and on the last one it's false, so it'll be true. And then now I have to look at the first part and accompany that with the second part. If they're both true, then it'll be true. And so the first part is true here, but then P, and here we have that so they're both true. So the first part's true and the conclusion is true, so this will be true. And then on the last row we have a true, and then the second part's false. And so that means we have a false. Once we've completed this last column, we can then answer the question, is it valid or not? In order for an argument to be valid, this entire column would need to be true. So, but we have one false, so the argument is invalid. So again, in order to be valid, we would have to have exclusively trues, all trues. If there's just one false, then it's invalid.